Okay, today in math, we're going to be starting Unit 3, and as you can see by the title, it is multiply by one-digit numbers. So if you don't already, you can pause the video. You need your math journal, your math book, some scissors and a glue stick and a pencil. Make sure you have those and then come back. Okay, so I would like for you to cut out your note cards, put them in this order, starting with commutative property, associative, and distributive. And then we're gonna go to the next page, and we have numerical expression, compensation, and partial products. Make sure you get them in that order. And then, yes, I want you to write down the definitions that you see next to the cards, but I'm actually gonna be adding a little bit of information to the cards as we go to help you understand the words just a little bit better. So again, this is all about multiplication. Let's get started. The first properties that you see on this page, the first two at least, should be something that you're familiar with last chapter in adding and subtracting. The commutative property of multiplication, very similar to the commutative property of addition, just where you can change the order of the factors, meaning the factors are the numbers we multiply together, but the product stays the same. The product is the answer to a multiplication problem. So you can change the order that you put the factors in, multiply them together, and you still get the same answer, the same product. That one's pretty straightforward. You might also hear me call that one the flip-flop property, because you can just flip and flop them. You can change their order and the product stays the same. Now the second one, the associative property, is very similar, but it starts to get into orders of operation, as in what do I solve first? And it's similar. You can see the same numbers, the same factors they used in the commutative property, but it's answered a little bit differently. So in this one, you can change the grouping or the order you solve or multiply in this problem. You can change the grouping of the factors and the product stays the same. So let's see what that means. How's that a little bit different from the commutative property to the associative property? Well, back to the commutative, I would go in order. 4 times 3, and then that times 2 is 24. So 4 times 3 is 12, 12 times 2 is 24. Same thing here. You just solve it right in order. I can put them in any combination of ways that I want to, as long as I'm using the same numbers. I'll get 24. But in the associative property, and when you see parentheses in math, it means to do that first. So maybe I can change the grouping of the numbers to solve it differently. Like I said above, if you see the parentheses, do that first. 4 times 3 is 12, and then you would have 12 times 2 left. 12 times 2 is 24. But what about the next problem? They have 4 times 3 times 2. The parentheses tell me to do this first. So I would have 4, the 4 stays the same, 4 times, what's 3 times 2? 3 times 2 is 6. So now I solve what's left. 4 times 6 is, if you guessed it or said it, it is 24. So in the first example, I solved 4 times 3 first, which is 12, and multiplied it by 2 and got 24. In the second example, I did the 3 times 2 first and got 6, and then multiplied that by the first factor of 4. 4 times 6 is also 24. So it's slightly different than the commutative property. It tells you which part to solve first because it puts it in parentheses. All right, let's move on to the last one on the page. It's the distributive property. This one is more complex, so we're going to take a second to break this down on what we see on this card. It says you can break apart one factor and multiply those numbers by the other factor, add them together, and get the same product. So for instance, let's just take a look at what that looks like in this first problem. I really wish they would have started with the original problem, which is, what's 10 plus 8? You're saying 18. Good. This original problem was 6 times 18. But maybe you're thinking to yourself, I'm not ready for that. I have no idea. I can't do that in my head. I'm not sure how to find that answer. The distributive property helps us break apart one factor, for instance, this 18. You break apart one of the factors into its place value positions. And that is where they got 8 ones and one group of 10. And they're saying that you can multiply the first factor, 6, times 10, and 6 times 8, and combine those products, add those products together to get the same answer as 6 times 18. And that's what they've done on the other side of this equal sign. They did 6 times 10, 6 times 10, and then 6 times 8, 6 times 8. And if you solve those two problems and then add the products together, you would get the same exact answer as if you actually multiplied 18 times 6, or 6 times 18. So let's solve it. 6 times 10 is 60. 6 times 8 is 48. And if I add 60 and 48 together, I get 108. Now I'm going to jump ahead to the standard algorithm and what we're going to work on later on in this chapter to prove that we're right. So we need to multiply now. What is 18 times 6? Does it match? Are we right? So let's see, I'm going to do this down towards the bottom. Let's do 18 times 6. So like I said, I'm going to jump ahead to solve a problem that we'll learn how to do later on in this chapter, but I'm just checking my work to make sure the distributive property works like I say it does. So if we take the ones place times the ones place, 6 times 8 is 48. Carry the 4 groups of 10 that we made it in 48. 6 times 1 is 6. 6 plus 4 is 10. We have no more numbers to multiply, and it matches 108. So that's an example of how the distributive property works. You can break apart one of the factors into smaller parts that add up to be the same number, multiply those by the first factor, and you'll get the same product, same answer as if you did it the traditional way, or if you broke it apart to help you do it quickly or more quickly in your head. Now, you can pause the video here and add on what you need to from my notes that I added on to each card, and then head on over to the next page. All right, so let's keep going. The next and last 3 words that we have for this entire chapter starts out with numerical expression. This one is pretty simple. I won't really need to spend much time on it other than going through what it says. A numerical expression is any number sentence that has numbers and at least one operation. Well, what do I mean by operation? Operation means addition, subtraction, multiplication, or division. In 4th grade, those are going to be the standard operations that we deal with. So by the word operation means to add, subtract, multiply, or divide. And that's it. Any number sentence that has more than one number and at least one operation is called a numerical expression. All right, let's move on to compensation. A little bit trickier, but another mental math strategy that could really help us out to be faster at adding, subtracting, multiplying, or dividing. It's called compensation, and it is rounding that helps you solve problems mentally. Here are the steps. You round one factor, you multiply, then add on or take away the extra amount gained by rounding. For instance, they start with 3 times 48. Well, I might not know how to count by 48s quickly in my head, but if I round 48 to the nearest 10 to 50, I can count by 50s in my head quickly. 50, 100, 150. 3 times 50 is 150. But I added 2 to 48 to get to 50. So what they're doing in the end, and I wish they would have explained this, where did that 6 come from? Well, if they added on 2 more to get to 50, what they really did was add an extra step in here. They got the 6 because they did 3 times 2 is 6. Because they counted by 3 2 more times than the 48. And that 2 more times is equal to 6. So if you did 3 times 50, and you added on 2 more to 48 to get to 50, in the end, to adjust your answer, you would have to take that away from what you rounded to. So 150 minus 6 is 144. So 3 times 48 is 144. We're going to do more examples of this as we move into the chapter. There's an entire lesson based on this, so we'll get more practice. Last but not least is partial products. This is kind of like the standard algorithm, or the standard way you just saw me on the last page multiply 18 times 6. Here's a different way to think about it. It's called partial products, and we'll work on this too in multiple lessons. So they have 16 times 2, and in partial products, you start in the ones place, you multiply the single digit number, the 2, by the ones place above, so 2 times 6 is first. Then you would take that same 2 in the ones place and multiply it by the tens place. And if there was more, if there was a hundreds place or a thousands place or a 10,000s place, you would keep multiplying that 2 in a diagonal pattern. 2 times 6, or 2 times the ones place, 2 times the tens place, 2 times the hundreds place, 2 times the thousands place. As many numbers as there would be in the top number, you always come back to that single digit number and just multiply. And then you write your answers below. For instance, 2 times 6 is 12. They did 2 times 6, they got their answer, they wrote it down. And then they did 2 times the 1. But we have to be careful here. That 1 in the tens place is really worth 10. So they're not doing 2 times 1, they're really saying 2 times 10. And that's why underneath they wrote 20. 2 times 6 is 12. 2 times 10 is 20. So 2 times 16 is 12 plus 20, which is 32, or 16 times 2 is 32. Again, we'll do a lot more practice with partial products, compensation, and the standard algorithm, which we'll get to later in Unit 3.